So now that we have an idea what polymorphism is, let's look at how we realize that within our coding structure. The key to it is a concept called overriding. This, again, is something we saw before. We've actually done this within our toString methods, but let's look at it in a little bit different context. Overriding happens in two different ways. One of the ways is we have an abstract class like we have in a payment card class up there. And inside the abstract class we can define an abstract method such as the remit funds. That abstract method has no implementation. We have no choice but to override it, and really the term override is less interesting than implement. We actually have to implement that method right there. But we're just using a common term for both here, so we're going to see. Where overriding comes in, and we'll actually see when we get to Java code, the word overriding will show up, is we want to ensure that we are applying our implementation to that method. We have a code structure that's going to help us make sure that happens. So in the credit card class here, we're saying, I'm going to remit funds, and this is how I'm going to remit funds for the payment card. And so I'm going to have my own method, and you can see in the UML here, I have the remittent funds that's abstract up here, and I repeat it down here that's concrete. It's not absolutely required that I do this, but I know I stylistically like to say, hey, put code here. So up top is abstract, put code here. If I don't put code there, I assume there's no lines of code that are written there. It's either continues to be abstract or it's implemented somewhere else in the hierarchy. In UML, legally speaking, you can choose to return and copy any method that's up above because it's a valid method that's out there, or you can leave it out and it's still there because it's up above. There's no rules on that. It's a stylistic choice. I'll also point out here the balance there is actually the pound sign. That pound sign means protected. So plus is public, minus is private, the pound means protected. The other form of overriding then is the prepaid credit card class, which allows you to change the behavior from the credit card class. So whatever was done here, I replace it. It's gone, I replace it with my own. So both of these are overriding. If I take nothing, an abstract method, and provide an implementation, or if I change the implementation, they're both forms of overriding. So the important thing within overriding is to know you're defining the right interface. The interface in Java is the method signature based off of the method name, the parameters, and the return type. And within the parameters, very specifically, we have to have the same number of parameters, the same type, in the same order. So if I have two parameters, not just a double amount, I have a double and a string. If I'm overriding if there's a double and then a string. But if I switch that and do string then double, I'm no longer overriding. I'm now overloading, which is a concept we're not talking about here. But overloading is basically when I have the same name of a method but I have different parameter lists. So we want to make sure we are always overriding when we're dealing with inheritance. And so given that, up top, I have an abstract method, in an abstract class, remit funds. I need to make sure, again, the parameters are the same, the name of the method is the same, and the return type is the same. Notice the abstract class, the abstract method, ends with a semicolon. I don't need an implementation. By definition, it's abstract. Down here, I have the curly brackets. I provide an implementation. So the public is required from the sense that if it's public up here, it's got to stay public down below. I can't hide it. But I can make it more, if it was protected up here, I can make it more public. So you have to be as giving with your resources as the parent class is, but you can actually be more giving than the parent chooses to be if you want to expose that for some reason. Understand that when I overwrite, I obliterate, wipe out, it's completely gone, that parent's implementation. The example we just saw was abstract class. I have to do it. There's no parent implementation. I have to provide it. But when I continue, if I do that again in a different class, that other behavior is gone. It's not callable externally. I've completely replaced it. So it's up to me to be aware of that and then accommodate appropriately. So one of the things we want to do is we do not want to copy and paste from parent class down to child class. We still have the option to reuse code using the super operator. And we talked about the super operator, remember, last time. The super operator we did with two strings. We call that super operator call up there. That's really useful here because that allows us to reuse that parental behavior that I just threw away. In the two string, I can include that text inside of there if I want to, as long as I agree with the same formatting, or I can implement it on my own. In most of these other methods, it might be the only way to get at some of that behavior. If I want to pay a credit card, I still can do that. Just maybe I add additional in my prepaid credit card. I have additional checks. I'm doing that or something in there. So the way this looks in code then is my credit card is overridden by prepaid credit card. Down here, I say, well, if the balance of the card plus the amount that is out there is less than the stored value on the card, then I will go ahead and remit the funds the same way a credit card normally does. If it's not, then I won't do it. I'm not going to complete that transaction. And there may be some other behavior that happens along the way. But this is the idea behind that. I can change the behavior, but I can still using super the parent's functionality. If I don't put the word super inside of here, what happens is I fall into a pattern called recursion. And recursion happens when I call my own method. If you intend to do that, that can work out just fine. If you don't, then you get into an endless loop and just keep calling itself, and then it would never, the program would die. It would cause it to fail. So within our structure then, overriding, whether it's abstract or whether that is out there, fundamentally is the same. I take that extended signature, the return type, the parameter list, the name of the method, and I repeat it. And it has to be as visible or more visible. It can't be less visible, as I said before. And then I change the behavior. I change the algorithm. Here's another look at it. So again, I had a product inside of there. It has a price. I can have a food product, which again has its price up above. I don't have to call super. I mean, say this.price. Since it's protected, I can access it just the same. I can just change the behavior. So if the date of today is after the expiration date of the food product, I automatically offer it a half price. I've changed the behavior. So for most products, the price is just the price. For food products, I've changed the behavior of what's going on in my class. Again, the access to the parent information, different context. You have the super call. The super call then goes up to the existing price. I wanted to show this again here to say there's a choice involved. In this case, I've chosen to have that price be private, which means the food product can't accidentally change the price. It can only go and get the price this way. So when I say price is equal to price divided by 2, I can never have it refer to this price up here. I can never accidentally have the price every time you say get price, because I can only refer to the local variable here, price. So it's a little stylistic element, but it ensures that this is encapsulated. I only have one place the price is being set and managed. A little side note here, the super only works one time. If I say I have a non-perishable food item, hey, Twinkies last forever, I can't say super.super.getPrice. That doesn't exist. There's no guarantee of having a grandparent out there, so I can't skip over that. That code doesn't work. I can only call my immediate parent within my hierarchy, within the class I've defined. So the question is, if I have some random object out there, how the heck do I know which of these silly methods gets called? Well, when I say p.getPrice, it could call any of the three. It depends on the object that's going to be out there. So think of it this way. If I go to the artist and say create art, I could be the artist up here. I could be a painter, or I could be a Pollock painter. The painter who sprayed stuff on the walls, just took cans and splashed on the walls and splashed with brushes and stuff like that. And so painting is you get paint and you put it on a canvas, and you have the splash painter, you have the throw it on there, you water balloon painter, throw it out there, which is a different type of painter, which it goes out there. Well, depending on which one you affiliate with, you will then call the appropriate one. In this case, get price could get the straight price of a product, could get the half price of the product, or get the non-perishable non-half price of what's going on inside of there. And so it's not the left-hand side that determines that. It's not the type of the variable, product P, that determines that. It's the method that's getting called and the right side of that, the fact that it's a food product. So in this case, it's a food product. I call the food class. I get that implementation when I go off and call it. It really is seamless inside of the Java code. This is something that you have to code. It's just something you need to understand how it works within your code, because that's going to have some ramifications of how your code executes, and you should understand that. If you've heard of statics out there, I just want to point out that statics do not have inheritance. It does not have polymorphism involved. So static is a class level item. So if I have a method out there, getPrice, which is static in each of these classes, it would not show up on any of those. The super doesn't mean anything here. The static invalidates that structure. So it's basically like saying, okay, you're all students in the class, and you all have behaviors of being student in the class, like, hey, what's the assignment? But I can't say, give me your refund bank account inside of there, and you're going to get that from anybody inside of there, because that's something that's unique to you as a person. That has nothing to do with you as a student. And that's kind of what we're saying when you make something static. It's no longer true for each object individually. It's true for each object collectively. It's true for each one individually. They no longer. I'm not explaining this well. When I make something static, it's no longer part of the objects that gets created. It's part of the class. So think of it this way. Change around here. I have a cookie cutter. And the thing I hate about cookie cutters is they're kind of hard to grab. So when I put it in there, put it in the dough, I want to pull it up, I've got to kind of reach around and do that. So let's say I take that cookie cutter, I weld a handle over the top of it so I can stamp out cookies instead. Welding a handle to the cookie cutter doesn't change the cookie. So when I define a method, that defines the shape of the cookie. When I define a static method, it defines the shape of the behavior of the cookie cutter. So I think hopefully that's a better explanation. If you want to talk more about statics, bring it up in one of the chats. Come and talk about that. It's not important for this class other than the fact I wanted to throw this out. You know, that it does change the behavior inside of that. It's something that's unique if you know what statics are. If you don't know what statics are, that's fine. Statics are, I would say, something I don't want most programmers to use, much less new programmers. They occasionally have value. More often than not, they cause confusion in code. I actually had a huge major production defect caused by statics. I could tell you about sometime. Again, you can ask me in the chat. But let me roll from there. All right, so we're going to see this in code. We're going to implement this in code, but now you have a feel for what overriding is and how it behaves. And so the best way to get a feel for it in code is to write code and make it happen. So that's what we'll do next.